Welcome back. You are watching episode 33 of the Mobility Talks, the web series by EIT Urban Mobility that brings the urban mobility community together for a lively exchange on topics and issues that shape tomorrow's mobility. With this episode, we enter our 7th season, and you can take a look at some of our past episodes on EIT Urban Mobility's YouTube channel, where there is a dedicated playlist for the Mobility Talks. Today, we'll be looking at digital twins for better mobility. And for this, I am joined by two guest speakers. Ralph Frisch, who is Principal Business Development Manager at the PTV Group, and Lucas Ambel, who is co-founder and CEO of Transcalenty. Welcome to the two of you. Unfortunately, Dr. Christine Pohl from the city of Wuppertal had to cancel this morning as she fell sick, so we wish her a speedy recovery. But I wanted to kick off this episode, Ralph and Lucas, by asking you, actually, if you could help me define exactly what is a digital twin. Now, I propose that I give you 1 minute to give us a definition of a digital twin, and the goal is to complete your definition before the cyclists cross the finish line, okay? And so I don't want to put you on the spot, so I'll give it a try first, okay? So can we get our cyclists up? All right, so my definition is that a digital twin is a combination of data points that create a virtual copy of a real-world environment, which can be an industrial process, it could be body parts, it could be a neighborhood. Having said that, I'm not quite sure how much that actually differs from an Excel sheet. So I am assuming that the virtual copy is also somehow a visual copy, where you maybe can navigate spatially as if you were walking in the real world environment. So I'm assuming that a digital twin is also an immersive experience, where you can see the virtual impact of any change you make as if it was in the real world. And finally, I would say a digital twin must evolve in parallel to the real world environment. So any change in the real world must be reflected in the digital twin. That would be my definition, just on the finish line. So Ralph, am I completely off track? You go for it, try and beat the cyclists.
Impressive, though. What you said already helped me a lot, so that I don't need to say this. So for me, the expression digital twin is, I think, a certain reward. Because if you can call a tool or an approach a twin, you have already achieved a representation of something that is as close as possible to the reality. In the context of mobility, to reach a twin, this is almost impossible. It's quite an effort, to be honest. But I think with my background as a transportation planner, a transportation model, what I will also show you later, is as close as it could be. As close as a twin as possible. But finally saying it's still wrong. So, but it is as close as it could be. So I can leave the rest of 7 seconds to Lucas.
Yeah, it's, I mean, a twin doesn't necessarily have to be a Siamese twin either, you know? I mean, there can be some slight variations, I'm assuming. Lucas, then, over to you to try and beat the cyclists.
Thank you very much. So I'm lucky that I'm the third one, so I can recycle and reuse quite some words that have been said before. I obviously noted down something, and I'm going to read this because I'm always bad at just rephrasing exactly the way I wrote it down. So for me, it's a virtual replica of a transportation system that is continuously updated with, and now is the word, potentially real-time data from a physical environment. I mean, this sounds like a very technical kind of description, but in the end, I think we agree already, the three of us, very much so. I put in the word real-time, and I think that's the aspect that I'd like to highlight today a bit more in my presentation. And I think one more aspect is that it actually feeds back to the real world. And that's one aspect that I'd also like to highlight today.
Okay, brilliant. So I think that already helps us to set the scene a little bit. There are maybe some slight variations on the accents that you're putting as to what a digital twin can do, but overall we're talking about using a replica, and in this context, using it as a replica for transport planning, but also then understanding urban mobility and improving urban mobility. And obviously, we will soon be giving you a bit more time to present some actual case studies, okay, of how digital twins will be used and are being used. After the case studies, we'll have plenty of time to discuss other questions and considerations around this issue. But first, I can maybe introduce you to the audience. So you were more than 140 to register for this episode, with attendees joining from all over the world, 33 different countries, with Germany, Spain, Italy, Belgium, but also attendees from Argentina, Australia, Hungary, you name it. So welcome to all of you. And equally, different parts of the mobility community are represented, with a big focus on the private sector for this episode, but also from academia. So wherever you're coming from around the world or within the community of urban mobility, we want to hear from you. So as usual with our mobility talks, we welcome your questions, comments, messages in the chat or in the Q&A tab. I will be monitoring and raising your questions and comments with our speakers. So let's get started then, and I'd like to ask Ralph to kick us off through his case study then on digital twins for better mobility. Over to you, Ralph.
So, Jean-Paul, thanks a lot for the introduction and warm welcome from my side. So, as already mentioned in the bicycle race at the beginning, for me, the ideal digital twin for mobility is a transportation model. And I would just like to show you two use cases then, how I want to then also confirm this. First of all, just a few words to myself. As mentioned, I'm the Principal Business Development Manager at PTV Group. I used to work also for Volocopter, for example. So we developed electrical air taxis a while ago, and this is still also, I think, a very interesting kind of means of transportation. Currently, I'm taking over as key account our businesses with Deutsche Bahn, Swiss Rail, and ÖBB. All those companies are already using our software quite intensively, and normally, I think, for over 20 years in the meanwhile. Just a few words to the PTV Group. So we are a global company with around 1,500 employees. Our headquarter is based in Karlsruhe. I'm also currently here in Karlsruhe. Our customers are more than 2,900 cities in even more than 130 countries. And I think just to give you one example about kind of our customers, the top 10 rail customers that are using our software. And so on the right side, you see already Baden-Württemberg in the background. So this is the road network of Baden-Württemberg. And as mentioned, I want to show you two digital twins. So the first one is a macroscopic digital twin where you see traffic flows. So always in a certain section or in a certain amount of transportation. So this is the Baden-Württemberg State Transportation Model, in short LFMBW. And then also want to show you a microscopic digital twin. So you see the movement of every individual, and this Frankfurt main station. This project is done by Deutsche Bahn, but I'm allowed to show you a few of the results. So let's start with the transportation model for Baden-Württemberg. Baden-Württemberg is called The Land. You might have heard of this initiative already from Baden-Württemberg that they put on this brand in the world. And I think from my end, the question comes up, and maybe you need to ask this in the end: is this really an ideal digital twin for mobility? The Ministry of Baden-Württemberg, they brought up quite a good explanation movie, and I would just like to show you that movie and explain you a little bit about the transportation model. So this model, as I already mentioned, is a nationwide transportation model, and it covers all means of transport, so the movement of people and also the movement of goods, and it is able also to show the current situation and also predict the future of public transport. So we are now in 2025, or last year it was released, and it can also predict the future. So in Baden-Württemberg, we built this up with also different means of transport. So you can, for example, so there is a station-wide network, including all different kind of transportation, so pedestrians, bicycles. So you have a multimodal approach of different means, and also then you see the impact. If one gets better, one means the other might get worse. So how it is done, so the whole country is divided in around 7,900, we call this traffic cells or traffic zones. We have the whole network of individual transportation, public transportation, 60,000 stations included. But the whole country is even incorporated into a bigger model. So because we also need to have the transportation or traffic that goes through Baden-Württemberg. So therefore we have around 2,000 traffic cells in the rest of Germany and Europe. And in total, so we have about 10,000 traffic zones. So that, for example, and if there's a truck starting in the south of Europe and is passing Baden-Württemberg, also this kind of impact is taken into account. But of course, the main aim is also to do some local calculations. So, for example, if you have there a problem that might affect your CO2 emissions as a transportation planner, you want to find alternatives. And in this model, to also ensure a realistic representation of traffic, we have data from traffic counts, household surveys. MID means mobility in Germany, Deutschland. We have all timetables, road and settlement network, all the population and employment statistics. And all these are linked together in a clever way in our software called PTV Visum. And then you are able to find, with this help, of the software, alternatives, so that you can, for example, plan new bicycle lanes, that you're able to implement a new tram line, or that you try to have an impact on the CO2 emissions. These kind of measures you can just play around within this model. And not even this, we also have, of course, implemented such modern and new, like on-demand services, AI control things, and also what is the impact on traffic lights, for example, and how could this then be used within the planning. So, and the good idea is, so, or the good concept is that the Ministry of Baden-Württemberg is giving this model away for free. So normally as an application as the city in Baden-Württemberg, you can get this model, you cut out your certain city, then maybe do a little bit of an improvement, but you can directly use this and plan multi-model with this model. This is one of the results, what you're seeing here, divided in three different views. So the very left one is the public transport, in the middle you see the car, and the right you see the bike. And what you are seeing here is traffic volumes. So how many people are traveling on this certain lanes or streets. On the very right side, this is the bike land, we call it, but you see this, the bar width factor is 10. So normally you would not see anything here. So this really, I think the first time I saw on this slide, I said, okay, wow, still in Baden-Württemberg, we are a car land, right? It's still quite impressive how much car traffic you still have there. And one of the ambitious goal for the Ministry of Baden-Württemberg was for 2030. So we talk about in 4 years, reduction of 55% CO2 reduction. I doubt, to be honest, that this will be reached. But until now, you can say, hey, how can we reach this, or how can we do it? You can ask this model about what could be the certain impacts of your implication. If you later do it, really, this is another topic. But you can you can see the impacts and results. What could happen and what you need to do to reduce this kind of CO2 emissions. So this was the first digital tin what I wanted to show you, and this was a macroscopic one. Now I would like to show you a microscopic approach, so where you see the movement of every single person, and this is done by Deutsche Bahn in the cooperation with us. And what you are seeing here, I think most of you might already have been there. It's the Frankfurt main station. So we start with quite a lower level, the concourse level, where the regional trains come in, and then you see pedestrians We call our software PTP Viswalk. You see these interactions. So, and it's now built up stage by stage. So the next is this concourse level where the people then also then walk from the regional trains to the long distance trains. And I think most of you have already been there, I hope. Maybe not those one from Malaysia, but in Germany, you know the station. So it's Frankfurt Main Station, and you see the dead end station where all the trains arrive. And then you see the pedestrians walking around the city, walking around the station, and then you see also the interaction. So of course this has an impact. We can calculate the travel times of the pedestrians. We can also generate heat maps, for example, where we exactly see directly, okay, where might be a problem when people just come together and there might be a critical situation. So this is the other way of producing a digital twin. And I think these are my two examples. And of course, I'm open for questions. And please contact me for additional questions. Jean-Paul, back to you. And Lucas, all the best for your presentation.
Brilliant, Ralph. Thank you so much. Maybe just a couple of quick follow-up questions. I mean, just to be very, very practical for a second. So to use such a tool, I mean, let's say you're a city. So Baden-Württemberg has provided the tool for free to your city within Baden-Württemberg. How many people would be using such a tool in a city? Like, what are we talking? And is it intuitive in the sense of, can it be used by, let's say, anyone in the city? Or would you require, additional support from, a service provider to help you through the tool? And in fact, maybe a service provider actually does these, simulations, let's say, for you. How does it work on a practical level?
So I think I would say until now, yes, it's normally the transportation planning department of a city or even a country that are using those kind of models. And they are normally transportation planners. But we are also aiming with new ways of software, web-based software, and also easy-to-use software that we want to get more and more also access, I would say, of not normal people. But I would say so that you also, if you don't have that experience, that you can also just use it and get an impact or a certain idea about what, if you change something, it has an impact. If you reduce the public transport headway, then the people might just switch to another device and private cars and so on. Of course, the more and more who can use this and who apply this would be, of course, beneficial. But as it until now, normally it's transportation planner and transportation experts.
Okay, and the second one, I think especially when we look at the microscopic example, and you actually see people in the train station, and that's always a bit of beef I have with the sort of futuristic images that you see of cities, the simulated images of what cities could look like in, say, 2050. You never see anyone in those pictures, or you might see like 3 or 4 examples of people walking around, but you never get a sense of the numbers of people that actually are and do live in cities, and so here it's quite actually nice to see people. But there's also a question then in the chat here. So how do you get access to data in relation to people, humans? So I mean, I'm imagining that's also coming from data, the number of people that we would see in the station. So, I mean, are you using sort of smartphone type data coming from smartphones or other kinds of tools, different sensors? How do you capture human related data?
I would say all of them. So the more data you have, the better the model it gets. So you can use all kind of different data. So is it, in this case, it's Deutsche Bahn. They normally know also how many travelers are in their trains, how many are commuting. But yes, sensors is a good way. Traffic, household surveys, for example, also is a good one. But yes, addition, of course, mobile phone data is, of course, absolutely a very good way of using it. At the end, put all those different sources together, make quality checks. Absolutely. This is, I think, what you need to do. But in the end, a model in the end is wrong, as I said at the very beginning. But the more you put into real data, the better it will be, and a better reflection the digital twin will be of your city. So yes, I would say I do not want to limit to anything. So as if the quality is good, and if you check the quality, you can use all kind of data to improve this digital twin.
Brilliant. Thank you, Ralph. And obviously, you stay with us. We'll be with you shortly,
Absolutely.
but we'll first then go to Lucas to hear another then example of how digital twins can be used for better mobility. Over to you, Lucas.
Very good. Thank you very much. Thank you also for having me here. Um, so I'd like to start to quickly introduce myself. So my name is Lucas. I'm a co-founder and the CEO of Transcality. We're a ETH Zurich spin-off. ETH Zurich is the technical university here in Zurich, and this is also where I did my PhD in transportation modeling. And where 4 years ago, actually yesterday, 4 years ago, we founded Transcality with 3 people, and now we're 13 team members. And what we essentially do is we build digital twins, and I'll show you in a bit how we do this a bit differently than this has been done in the past. But we were lucky enough to work already with big names like Transport for London or the Swiss Federal Highway Authorities, or obviously also the city of Zurich. And with that, I'd like to quickly start into the presentation. So I think the problem was already illustrated well by Ralph, right? I think it's very similar questions that we're trying to answer. Essentially, from a big picture perspective, I would say changing infrastructure, changing mobility requirements, together with increasing urbanization, puts a lot of pressure onto the existing network and into the existing kind of transportation networks. And together with the net zero targets, which especially European cities have put themselves to as targets, it creates many questions around, for example, what happens if we close this main bridge for a month, right? So typical question that Ralph could answer with his models. I'd like to focus this time here a bit more on the second question, which is more a question that you could ask for a real-time operations perspective. So how can we alleviate the traffic congestion that is caused by this road closure right now? Could be an accident, could be, for example, a water pipe that breaks right now, and you'd like to understand, okay, how are we going to handle this at this moment? How can we take influence so that this doesn't create much congestion and a complete collapse? And obviously, we can also start answering questions with digital twins, like what happens if I close this lane for motorized traffic and introduce a bicycle lane instead. But today, I'll be mostly speaking about the operations part. And what we essentially try to do at Transcality is build very large micro or mesoscopic models, like the one that you see here for the city of Zurich. So essentially, we take everything that moves around and we try to replicate it in a virtual replica, as I just said. And we try to do this not just at the intersection level, as you see here, but really at the network level. And secondly, we try to do this as much as possible in real time. Now, what does that mean from a digital twin definition perspective? I think I already gave it in the very beginning. So what you see here is really this idea of replicating the world, the real world in a twin. And what sometimes people would say, and again, right, I don't think the definitions matter so much. I'm happy that there's different definitions. In the end, digital twins are a tool. But here, what I understand, most of the time when you go from one direction to the other, so when you go from the real world to the twin, sometimes this is also what people call a shadow, because what you don't do yet so much is you don't go back directly within the results of the twin. So you might be building a bridge, yes or no, right? So that might be your way back to the real world. But what I'm trying to show you today is really something that is a direct linkage back to the real world when it comes to the traffic operations, essentially traffic control. How do we set up such a digital twin? This is where we differ a bit from others. Essentially, we have spent a lot of time in trying to automate the whole process. So essentially, when we built, you can imagine the network layer, we built this as much as possible from openly available data. But on top of that, we also try to basically have AI help us ingest the data, which is very heterogeneous, which is very fragmented, making sure that it makes sense. I always have this one example outside of the city of Zurich on the national highway where one detector reads 2,500 vehicles per hour, the other one reads 3,500 vehicles per hour, and both are actually on a stretch of road where there's no exit or entry. So obviously one of them is measuring it wrong, or maybe both of them. And so making sense out of the data, as Rolf put it before, is a very first step, which is extremely important, right? And this is what happens in this first data ingestion part. In the second part, where we wrote AI and simulation, is where we use AI to do a short-term prediction of what will happen in the future. This is something that AI is very good at, right? So essentially understanding the pattern that has happened before. Whereas simulations are really good at things where they haven't been observed yet in the past, right? So having an accident in exactly that road that you're observing it now is probably something that hasn't happened in the past 10 years. So finding that exact pattern is going to be very hard. And this is where we use actually simulations like the one that Rolf showed you before. I'll show you which simulation engine we use in just a few minutes. And at the end, we have a platform, just like everyone else. It's web app based, and you can access it. But I'll show you how this looks in just a second. The digital twin use cases for a real-time application that I'm trying to show you here are, if I may say so, these four. The first one being a real-time monitoring. So you can already see the screenshot on your right, where you can see it looks like a bit of a Google Maps of the current condition. Obviously, it's not just a Google Maps, it's also telling you what the flows are on different roads. It might tell you what the controllers are doing right now, so traffic controllers. But it might also give you the ability to play back the past. Many of our customers actually tell us, why was last Tuesday such a different Tuesday than it was today? And in order to analyze that, we need to somehow go back into the past and be able to visualize and double check what were the effects on that specific Tuesday. The second aspect that we can do with a digital twin is essentially traffic prediction. So here, what I'm talking about is not doing a prediction for 2050, but it's about telling you what will happen in the next maybe 15 minutes, maybe 30 minutes, maybe 2 hours. And to activate basically a proactive traffic management. That might be not at the intersection level, but it might be at the network level, where you might deploy certain strategies a bit earlier or a bit later than what your more reactive traffic controller would usually do. And the third option is a clear one, which is the what if scenario analysis, which is essentially, okay, what happens if we close this lane right now, for example? And the fourth one would be a strategic traffic management and the automation thereof. And I think this is also fairly clear with the example that I gave before. It could be that you have predefined strategies in the back where, depending on the emissions, for example, you deploy certain different changes as speed limits or as gating policies, et cetera, in real time. Now, let's have a look at a specific use case that we built. We did this together with a company called Swarco, which some of you might be aware of, which is a large ITS, intelligent traffic system provider. They build a lot of traffic signal and traffic controllers, and they have a system which is called My City. This is the little bubble in the middle. And essentially what we build on top of My City is really this digital twin approach where we added a layer of the simulation, and we received the data from their traffic controller and from their traffic detection system. Probably best explained in the next slide. So what we started out with for a city called Landau in the Pfalz in Germany, what we built essentially is the road network from OpenStreetMap. We then added the traffic detectors, as you see in the second step, the little yellow squares. Those little squares were actually directly connected to My City. So essentially, they were the ones that gave us the real-time API to understanding, okay, how many cars or how many bicycles, etc., drove over a certain stretch of road. And then in the third step, we would actually gather the traffic signals in what is called a OSIT format, which is a fairly familiar format in the DACH region. And in the end, we were able to then actually gather as I said already, the real-time traffic data from the broker of the My City product from Sorgo. And how that does then look like, this is the small simulation that we built. This is now built on Sumo, which is an open source version of a micro or mesoscopic simulator. You see here the little arrows being the little cars. So really every car was also the one that we statistically had in the digital in reality, right? And maybe the last thing that I'd like to demo is really how did that then look like to the customer side. So essentially Landau got something like this, which essentially showed them from a base network, what is the current flow? What is the current speed? They could also look into emissions right now, but they were also able to change the speeds, for example, or change the lanes permissions, meaning that they could close a certain road and see what would happen instantly in the next 2 hours, for example, if we were to do this from a flow, from a emissions, from a speed perspective. And you will see in just a second when we scroll down a bit afterwards in the image, so we could actually compare two different scenarios next to each other, but you could also go into the future as of in the next 30, 45 minutes and see what would be actually the effects, what would happen if we would do nothing, and what would happen if we would actually deploy that strategy. And that strategy can be changing traffic controllers, changing essentially what kind of let's say green times we have at certain intersections, etc. Or it could be changing the way we understand what's going on in the network because of certain events that took place and then react directly upon them. And this is the digital twin view that I wanted to give you. I hope everything was clear. Otherwise, I'm happy to answer any of the questions. And I'm obviously also happy to connect after this talk. Thank you very much.
Brilliant. Thank you, Lucas. I mean, I think we see very different ways here in which digital twins are being used. Maybe a quick follow-up question for you, Lucas, a bit similar to the one for Ralph in terms of how user-friendly then these kinds of tools are. So what are we talking in terms of teams? Are we talking some kind of external service provider supporting teams within public authorities, or is it quite an intuitive tool?
So I think this is where we try to differentiate ourselves a bit. We really put a lot of effort that it is as simple as possible. That obviously means, right, that not every single feature that you would have in a PTV Visum, for example, is available. It's clear, right? So with simplicity comes a certain level of reduction of features, but it allows essentially many people to access the model to actually play around and get answers fairly quickly. I think with AI, if I may extend the question a bit, I think with AI, there's a great chance, not that AI takes over for decisions, but for the interaction with such tools. Imagine that you could basically interact with such a model in the same way as you do with ChatGPT or whatever AI tool you're using, which would basically mean that you would ask a question like, what would happen if I close this road here and there? And the model would run it and give you the feedback immediately.
Mm-hmm. Okay, and another question that just came in. So do your customers use the digital twin for public transport as well?
Good question. So right now, we focus mainly on modeling transportation, modeling public transportation inside the model, but we do not have the interface yet ready for people to play around with public transport. So it's modeled, but it's not playable right now. So it's part of the roadmap.
Okay, wonderful, and I think we can bring on Ralph as well. So we're merry, the three of us, and I'd like to tackle with the two of you a question that has come up in relation to transport engineers that have used simulation models for a long time, and you refer quite often to simulation, and it seems like the digital twin is a simulation. And so the question is, what exactly is the difference then between a simulation and a digital twin? because it seems like they're quite similar. And a digital twin is a simulation. So what else does a digital twin bring that simulation does not? Is it to do with patterns that a digital twin can recognize more than a simple simulation? Is that something that I've picked up? But maybe Ralph, you can have a first go at that.
Okay, so if you're really speaking about a twin, so a twin is more or less the same. And I think both of us, or rather Lucas, know we will never be able to that, especially if you talk about such a complex thing about as mobility, to get it to a real twin. So because there are so many implications in real time or in strategic way, like we have shown it. So that a simulation always helps you that as close or modeling as close as possible to come to a digital twin. But I think you will never be able to reach this real digital twin. Maybe I don't know, 30, 40, 50 years, if we can apply AI in, I think, in a way that we really know what we are doing, maybe. But I think this will still last some time.
But isn't it the case that the digital twin is more than a simulation because it is incorporating analysis that a simulation would not? I mean, I have a feeling that a digital twin is much more interactive with the real world environment, and the simulation is more static. That would be my sort of understanding. And so with a digital twin, you're able to recognize patterns and adapt, whereas in a simulation, you would have to do that yourself. You would have to tell the simulation what it is changing all the time. No, Lucas, maybe you want to chip in.
Yes, I mean, it's a hard question in a way, but I very much agree with what Rolf said, right? I think you also said all models, I mean, you didn't say it this way, but I will say the way I learned it, right? All models are wrong, some are useful. So I think this is very much true here as well, right? So essentially, a simulation being a twin, yes, at some point, but as Rolf put it, mobility twins or mobility simulation at its very core, we're trying to replicate the behavior of people. And replicating the behavior of people is just extremely hard. It's just like trying to walk in a very busy station, as you showed before, and then, am I gonna go left when the other person is going right, or the other way around? How are we ever gonna be able to really precisely define that? I think there's no chance. Even with AI, I don't believe that this is gonna be possible at any point in time. Nonetheless, I think digital twin has become a word of, in German you say Modewort, and how do you say that in English? It's like a word of fashion. I'm not sure that's the correct translation, but a fashionable
Trendy
word,
somehow.
a trendy word, which I think people that have done simulation in the past would just say it's a traffic simulation, right? I think one part that you could argue, and that's what I try to argue sometimes, is that a twin really tries to go back and interact with the physical world as well. But I think that's just playing with words.
Maybe I can add one thing, Jean-Paul, to this discussion. So because when we both say, hey, it's not, the model is still wrong, but I think, as I mentioned, so more than 2,900 cities are using our software. Deutsche Bahn, they have 90 licenses from our software, and they're doing the whole strategic modeling of their ICE trains, depending on certain infrastructure measures up, for example, 2040. We can always say, luckily enough, we are not responsible for the current delays. This is always what I keep on saying. But hey, there might be a reason why they're doing it, and why they might invest all this effort and also money to do that. Because what would happen if they won't? They would know nothing. And now I think the transportation model is still the way best possibility to have an overview about the current traffic situation, also what Lucas showed it, but also do the prediction. What will happen if I have a certain infrastructure that also minimizes or restricts me to a certain way? What will happen? What will happen, as I said in the what I said in the before, if you have a public transport line and you reduce the headway from 20 minutes to half an hour, the people will switch. There will be a model split shift to another way, what you maybe do not want. But the whole situation is so complex, so that if you just, okay, I know what will happen if I do that. No, you won't, because there might some restrictions that has an impact what you never had in mind. And if you have this digital twin, what we both have, of a city, where you have the network, you have the timetable, you have everything what you could have, then you still have the way best possibility of predicting the future or know your current traffic situation.
Yeah, because it seems that a digital twin in a very sort of closed environment where you would have a control over every single factor, like a kind of an industrial process, let's say, I can well imagine that it would be a very valuable tool, because you can tweak a couple of aspects and you would have everything else remaining the same. So you could predict very accurately what an outcome could be. But the moment you go into this open environment, you're saying that the model will be more and more wrong. On the other hand, you're saying it still provides a lot of information that you wouldn't otherwise have. And so I suppose the question is there more of a risk that the results could lead to misleading interpretations, and so you might make a certain number of assumptions that lead you to make the wrong decisions, and so that's a risk? Or do you think that the benefit of just at least having some level of information is much greater, and so therefore there is no risk of misleading results? And maybe if there are misleading results, do you think the model is, let's say, clever enough to take that on board over time? And maybe you even have examples of that. It would be really interesting to hear. So risk and benefit, I would be really keen to hear you on that in the context of this very open environment, which is urban mobility. Lucas, maybe you can have a first go.
Thanks. Personally, I believe that the benefit outweigh the risk manifold. So I really have seen in the past cities that have not had any model or not had any digital twin, whatever you want to call it, and that made decisions that then led to basically a chaos. And in that case, very quickly, people then turned to modelers or to engineers to double check, okay, what went wrong? And I think this is really, when I said all models are wrong, it didn't mean do not get a model, right? It meant that just understand the limitations of your model in a way, and also understand that not everything can be perfectly modeled. And I think that's exactly the point that I think you're hinting towards, right? Is essentially understanding the limitation of your assumptions, right? And also then being able to interpret the outputs. And I think one of the things that bothers me in this world of modeling a bit is that sometimes we just say, at least when I look at some models, it's like, oh, this road, it's going to be 205 vehicles per hour. And that's just the number, right? And the other one is 392 vehicles per hour. And I think that's something that we as modelers could improve, is to actually give some uncertainty range and say, look, not every day is going to be the same as every other day, obviously. But in addition to that, our predictions have certain uncertainty. And I think educating our clients in a way on the uncertainty is something that we need to become better.
Mm-hmm.
Not sure if I answered your question.
So Paul, can I
add
just 3 different additional use cases to the importance of modeling? So situations that you might not be able to predict. So currently, unfortunately, we live in quite uncertain times. So about discussions about resilience or dual use of our infrastructure. What happens if there might be some military use cases where military, I don't know, some forces or something needs to be just shifted from one location to another, as an example? How would this work together with existing people that are traveling? This is something you could not imagine how, but with a model you use this kind of thing. Baden-Württemberg is also a good example about sustainability, CO2 emissions. There might there is this what Baden-Württemberg was saying. We need to reduce the CO2 emissions up to 55% until 2030. Okay, how can we do that? What kind of measures could we implement? And what is then the impact? So this is exactly kind of things what you can prove or show. Even if it's a failure, then you need to change your infrastructure measures, for example. And the last thing what I would like to mention is there will be autonomous driving coming up, right? And hopefully in Germany we implement this in public transport. Otherwise, you will have I don't know how many autonomous taxis on the road. Could you imagine what kind of impact this has? So there will be just more, and then you have a way of as also a city to have a certain says okay, we have used this and we have modeled this kind of application, and in our city we need to have restrictions up to certain. Otherwise, our traffic will implode. And these are just three ways how we can use transportation models or digital twins also to show impact.
There's a couple of points here, which I'm going to say are linked to qualitative data. Sorry, so we've been talking a lot, let's say, about volumes and metrics that amount to figures that you can more or less influence by making changes in the digital twin and seeing a pathway. What about qualitative aspects such as, for instance, accessibility? Information and how that also then interacts with user behavior in public space with mobility options. I mean, Ralph, again, you were showing in that microscopic level in the train station. I mean, how much are you able, or how close can you get to having also that kind of data influencing the model? Is that still very far away, or is that already part of your systems? I don't know, Ralph or Lucas, whoever would like to try and go first. Lucas, you go for it.
Okay, so I think this is definitely something that PTV has more experience in as well, right? It's more of a strategic kind of question, longer term decision-making process. Um, I I always had in my mind is the complexity of a model should not be out, kind of going crazy, because then it really starts to be really hard to follow up what are the main drivers behind the changes, right? And I think, as Rolf put it before, what we want to be able is with a model or with a twin, we want to be able to understand the main driver of a change or of something that we intend to happen. And so if the model becomes so complex that it can actually, predict the frog that will cause an accident that crosses the road, then I think there's just going to be so many things that we have to consider that the model becomes such a huge thing that it doesn't, you can't run it anymore. So I'm a fan of simple models which you can couple with each other, right, and have a, one output to the other, but you still control kind of in a way what happens and why is something happening. And that means really the interpretation of the model still is feasible. So yes, add as much complexity as you want, but please do understand kind of what drivers it then influences.
I fully
Ralph,
support your
maybe
point, Lucas. I fully support your what you just said, Lucas. But as thing is always, there's quite often also simply the request from the people that are using the model. Hey, we want to implement on-demand service. We want to implement this. We
Absolutely.
want to implement autonomous vehicles and so on. And then, therefore, because you need to have answers on that, you increase the
I
complexity.
agree.
But absolutely what you're saying, I think if you have just, I would say, like building blocks or something what you can put together, yes, I think we should exactly think in that kind of direction. Sorry, Chopin.
and
I
yeah, It's just to try and understand also then from the city perspective, so the demands, right? So there will be use cases and scenarios that cities or public transport operators or transport authorities will be looking at digital twins to help them with, and I suppose that will be driving the model to some extent. And so if someone's interested in yeah. A scenario for an aging population, they will need to consider accessibility data, and the model will need to focus in that direction. And you might then have to cut elements from that model to make it a bit more simple to focus on that, let's say, factor or on that use case. So maybe I'm just curious to understand what's driving what. I mean, so I think in the end, you can make everything to some extent simple enough and focused enough on a specific metric that you're trying to improve on. And so are the models telling the authorities what metrics they should be looking at, or are the authorities telling the models to help them focus on certain metrics? if you see what I mean, I'd be curious to hear you on that. Lucas, yeah.
Sorry. Well, so just giving one use case that comes to my mind is in Switzerland, for example, noise regulation is one of the big topics always, right? And there's obviously models that can give you from road, basically from vehicles that you have in our models, they could give you directly the noise emissions or emissions. And when we talked, however, to the authority that produced these reports, etc., they said, no, we have our own model, and you can give us your outputs from your model, and we will then input that to our model that is specifically for noise. And I found that quite fascinating. That I think there's both things. There's some clients that want everything built in one, and that there's others that do kind of these modular setups, which we discussed before. And I'm not sure which one is the right way to go, right? I'm just saying that obviously it depends very much on the KPI you look at. Noise in Switzerland is a very regulated one, and this is why there needs to be a separate model which is accepted by all the stakeholders. And then that's the big word, right? Acceptance, in my opinion.
Yeah.
What I would like to add.
Is there some interoperability then? I mean, do you work on that, like trying to integrate different types of, data sets and different models into one, or would you rather recommend that models sort of specialize somehow in various metrics?
And it's a hard question. I personally am a fan of the modular one. Sorry, was this question for Ralph?
Well, I thought it was for
No,
Ralph.
fair enough.
Good, go ahead. No. I thought it was a follow-up question. Go ahead, Ralph.
No, Jean-Paul, what you said, it came to my mind, again, the data, the availability of the data, and also I think those typical, you mentioned elderly people or students or maybe employees, so different kind of population, parts of the population. And I'm not a fan of to write AI over every single thing, but in this case, AI could really help to get you the data. So what we currently, for example, have is we have a product called Model to Go. So that helps to build those models, what I've shown you before, easier, because the availability of data is easier. And for us as transportation modelers, it was always a mess to get the right employee data. So where are the people located? Where do they work? Especially in Germany. But you get now more and more data about the buildings, about the height of the building, about the sizes of the buildings. And the good thing in Switzerland, you also have the information about how many employees are there. So we trained an AI to predict the employees in Germany out of Swiss data. And this is kind of and there are a lot of different approaches and idea where you can put different sources together. I mentioned mobility in Germany, Mobilität in Deutschland. So this is a super good source. And when you combine those different sources, the quality and the end of your data is really, really high. And then, yes, you can put all this different together because, of course, they have an impact on each other. depending on certain. If we are building up a transportation model, we, of the one hand, have the transportation supply, so the timetables and everything, on the other hand, but we also have the demand. And this demand comes from a certain, we generate the demand within certain algorithms. And therefore, you need have this different input because elderly people totally behave differently in a pattern as students. But if the data and then you can implement these different behaviors, you can build up a whole population and you know how they are traveling.
So I have another question for you, Ralph. There's someone from Barcelona metropolitan area, basically saying that digital twins are usually approached at a single city level. You were talking about in your model how Baden-Württemberg makes available this infrastructure to all the cities, basically within the region of Baden-Württemberg. But the question here is, so have you seen models where you can integrate several cities under one model? And also, how feasible is it to build and maintain these models at that scale? So Baden-Württemberg kind of makes it available for its cities in a region, but if that's not happening, can you get to that scale without it being, an unreasonable cost for cities?
I think absolutely yes. So what I just mentioned with this model to go approach, so you get much easier to the essentials of that kind of model. And by the way, also we use this kind of tools for building up the Baden-Württemberg model. So I said the supply on the one side. So there are networks, there are OSM networks. So we have the streets and the roads and everything. But you have TomTom data, you have here data, you have all that kind of suppliers that you don't need to trace every single road, but you can use already this supply. For public transport, you get all the data by GTFS, so you have current timetables, you have all the lines and everything, what you can also update quite quickly, and this can be put into the model on the one side. And on the demand side, what I just mentioned is how we generate these different approaches like students and so on. This all comes in at the end. Our goal is that we can more or less help also transportation planners to generate in a kind of an automatic way. I still think there might be the intelligence of the transportation planner used, but at the end to help to at the beginning to get this data and then to generate those models and then have much more time, for example, also to calculate different scenarios, to invest more time in different options and also in the quality checks. So as an answer, yes, already it is possible. In this station-wide model, this was already implemented, but with this way of getting or the availability of more and more data, it's much more easier to generate and build up those kind of models.
Okay, thank you, Ralph. Lucas, I mean, we've been talking a lot about, public authorities, transport authorities using digital twins. I mean, are these then the main kind of beneficiaries of these tools? Are these the main users? Or do businesses also use these tools for urban mobility? We're obviously looking at urban mobility only. And as we were having this conversation as well about the similarities in the end between simulation and a digital twin, I'm also wondering whether digital twins are somehow used then to also allow for potentially citizens or specific target groups or population categories in one way or the other to also then be able to be in a kind of immersive environment or understand changes and maybe even contribute to policy or to developments in a city. I'd like to understand a little bit the interaction between digital twins and their users and beneficiaries, and if we're covering the full scope yet.
Yeah, I love that question because it has always been a bit on our minds, right? So I think to answer the first part, are there any other users than the public authorities? I think clearly yes, right? It depends on how wide you want to take the circle, right? The first circle is clearly the modelers inside the city, right? So if they have any. But then the second circle within the city itself would be planners, right? So it could be project planners that have no background or not much background in transportation, but just want to understand, okay, if my plan of replacing this main street with trees, what will happen? Is that actually going to be as catastrophic as everyone says? And I think then come more and more kind of citywide employees. And then it goes to the outside. And here I think clearly engineering offices, consultancies, right, are the ones that then consult for the city using one citywide approved model, for example. But I always love to have that vision that if the tool is simple enough, and if cities, and I think the second one is actually the harder one, if cities or authorities are willing to do that, to have such a participatory kind of approach, right? So I know that there's companies out there that I'm not going to make a lot of publicity, but that actually do detection, right? That you can buy basically their device and you can hang them in your at home, right, on your window, and then they count how many cars, how many bikes, etc., and have this participatory kind of idea. And I love that idea. And I also love the idea that people could actually check whether what the city is telling us is actually also really the case, right? I mean, from a democratic point of view, double checking and kind of, having checks and balances is the essence. And I think I would love to see this. I am not sure cities and authorities are ready for this. And I also understand why, right? Because every time they open up their books, they get, all different political parties that tell them, okay, this is wrong or this is good, etc. And there's a whole discussion going on. So they'd rather have a kind of, let's say, clear book on what they want to do. But as a wish, I would love to see that.
Jean-Paul, may I add two additional use cases to that? So what you mentioned, so business to business. One would be, for example, the provider or supplier of charging stations. So for electric cars. So where do you put those charging stations? So with a transportation model, you excel exactly how many cars are passing by, and much more important, you know where they're coming from and where they're going. So you'll not already know, okay, what kind of distance have they reached when they come to that point? So do they need to charge, or where do they charge else? With transportation model, you can have good applications of accessibility. So, and even or more complex accessibility. What we also have talked to is real estate. So, for example, for a website of someone who is providing real estate, you can have, okay, there is someone looking for a certain real estate in a country, but how is the surrounding? We have the data. So how many kindergartens are around? Or the one person lives in that area, the other one's in the other. On my way to work, can I just leave my kid at the kindergarten? How many schools are there? How many shops are there? So what could, of course, improve then the quality for a real estate provider quite a lot. And these are just two examples. I said, hey, this could be an improvement also for business to business.
So you're giving a picture of a quite modular setup. It can be extremely tailored, very custom. I'm imagining you're building these models very specifically for whatever use case that you're looking for. But then ultimately, everything comes back to my initial Excel sheet definition of the digital twin. I mean, there is data underpinning this. And that data will be also the success of the model. And the quality of that data will be essential. And the more you go to scale, the more you will require several data inputs. And the more you risk, either using bad quality data or finding situations where data is just not interoperable or is creating, confusion. So how does one ensure that you are using sort of quality data, but at the same time sufficient amount of data to feed in these models? And I can imagine that there will be lots of, I suppose, contractual aspects behind the scenes that you probably need to solve. So Can you take us through some of the main hurdles that you face with accessing data and using data and checking the quality of data, and how you somehow overcome those hurdles? And let's go to Ralph. Let's go to Ralph first.
Yes, I get your point. But to be honest, I don't worry so much about this. So I think the data availability becomes better from day to day. And in that case, also to do quality checks, everything, AI is really helpful. So you can do a lot in that combination. I'm still a little bit worried. We could have much more data, also regarding data security protection and so on, GDPR. In that case, it's for transportation model, it is not that helpful to have this strict, but of course I can understand the background of it. But and also I think a lot of companies already thought about interoperability. OSM, I think it's also a good way of, there you see already a good way of collaborating together. And also even the big companies, they team up. If you think about the company here, there are several automotive came together and they're sharing because they know, hey, we need a common and want a shared approach here regarding networks. In public transport, there are certain interfaces and APIs that are also defined. And for example, you have in Germany, there's a VDV interface where you exactly know how the data, for example, timetables, everything is coming in. So you can also exchange that data quite easily. So I think there is an increasing also, I would say, responsibility, or also that the companies are aware of that situation and try to improve it via standardized APIs.
Mm-hmm. Lucas, would you like to add something on that?
Not sure how much I can add because I very much agree again with Ralph. So I do see the same trend, right? I see a trend towards also openly or making data more open, especially also from authorities, right? Publishing their own data. What we use at Transcality is really a multitude of different data sets. It's not just, it's not just loop detectors that you saw before in the presentation. It can be floating car data, as Ralph mentioned, right, from GPS providers. They can also be camera data. And we basically put layer of layer on top of each other. And then essentially the art of it is then to identify which one of the detection methods or which one of the detector is the one malfunctioning, which one can we kind of deal with. And I think here again, I agree with Ralph. I think here, this is really where AI trumps all other methods, which really is kind of then taking into account all the different patterns and then figures out, okay, that one just cannot be the one, if you remember the example that I brought, which was 2,500 on the highway and then 3,500 on the same highway segment without in or exit. I think this is when then exactly these type of checks can work. I think one of the tricks that we use a lot is just really looking at the time series overall. So it's not just looking at a specific time interval, right? But it's really looking at the evolutions. I think these are the things that help. But it's really a game of numbers in the end, right? The more, the merrier. And if we can kind of tap into existing data sets, that also helps to double check what we receive from outside data.
And maybe
I
also
mean,
just to add
obviously,
one thing, Lucas, what you just mentioned. So also we have software called PDV flows that is similar to real time. So I liked a lot that we had the strategic approach and you had the real time approach, so that you were able to show both things. But I think we also there might be a little bit of an overlap of both ends. But what you also just mentioned is, I think this is super helpful, historical data, right? If you have certain patterns or time series from historical data, and there's one detector data, for example, that seems to be strange. It doesn't fulfill the expected ranges. So then AI, for example, helps immediately to show, oh, there's a difference. Maybe you need to check your detector out of these historical data and out of these historical time series. I think Joe Paul, this is exactly a kind of a way how it helps to ensure and to the quality check of your data.
Mhm. And I mean, Christine's not here, unfortunately, but from your experience of then, to come back to maybe the point made from our colleague in Barcelona, with several cities potentially having to work together to create scale. Um, Again, you would need to have a situation where these cities somehow agree to a framework to share data, have this data being pooled. I mean, yeah, so I suppose that will be done in a trusted environment in one way or the other. But I'm sure that there must still be some sort of contractual elements and some safeguards and some hurdles, and it can't be so simple to get that scenario where several cities are working together, pooling data, even if they somehow see the common goal that they might have. But I'm sure there will be many people who will try and limit that. No, is that not something you come across?
Um, I'll try to go first. So this is actually something that I wanted to mention before, right? So I think one of the key differences of the data providers in our case is that in many cases it's the public governments that provide the data. So there are in many cases uh, it's not such a competitive thing between different cities. Yes, obviously you always want to be the most livable city, etc., right? Or the most livable country or whatever it is in the end. But what we see very much is that there is kind of a data sharing going on between authorities. So at least in Switzerland, very federal kind of system, right? Where a city and then you have a canton level and then you have a highway authority level. And essentially all of them seem to work quite well together to be fine exchanging data. And I think that's actually one of the key advantages of this industry is that we're working with people that are not really in direct in competition when they're about to share data. I'm sure it's not always the case, and I've seen other cases as well in the past, but the majority of people that we work with, that is actually a big advantage. Not sure if you see it the same way, Ralph.
Lucas, I fully agree, and I just want to add one more thing where we more or less are forced to work together. This will be autonomous driving. Imagine, so you have a city or you have a country, and you have certain regulations, and if you have an autonomous vehicle, should it, and you have, I don't know, think about left driving, right driving. So at the end of a country, so normally then the autonomous vehicle would stop at the country, at the countryside, at the border. This we need to overcome this, and therefore I think we need to collaborate with each other. Otherwise, this and autonomous driving will be coming for sure, and therefore it's essential to collaborate and share the data.
And just as a startup, Lucas, in this field, I mean, you have, for instance, grown in the last 4 years. I understand. So congratulations. And access to data has not been a problem. For instance, I mean that also kind of to some extent
I
shows that
yeah,
even a
yeah, yeah,
startup
it's a
can
good.
access data and.
Yeah, I think that's actually a good question. It's funny, I've never thought about it because, to be honest, data has not been the issue, right? I'm not saying the quality of data has not been the issue, but I'm saying getting access to data, it's not something that people would then say, you're a startup, you do not have the level of credentials. I think what is more important is what comes now more and more are all these critical infrastructure regulations, meaning that whatever you deploy, because we are web-based, right? We need to show in many cases that we adhere to ISO X and Y, etc. And I think that is actually a higher burden than getting access to the data. It's showing that once we get the data, we make sure that it's not going to be shared with the world, essentially.
Mhm. Yeah. Yeah, you can put safeguards on that. So I would like to finish with two last points. The first one is just to get an actual sense of the cost of something like this. I mean, are we talking a big investment for cities? Obviously, you don't need to put an actual price tag, but it's just to get a sense of scale. I mean, are we talking a big investment? Or are we talking a minor investment? And are we talking a long-term investment, or are we talking a short-term investment based on a very specific simulation and case study that a city might want to carry out, and then they move on? So I just want to try and understand in a way like the market dynamic for such a tool. Obviously, don't go into the specifics, but just to give a sense of scale. Who would like to go first?
I can start if you would like to.
Go for it.
So, because I have shown you already, so in the case of Baden-Württemberg, for example, so the ministry was paying for building up that model, this multi-model. So, and all the cities, they can take it. So is that in Switzerland, there's a whole countrywide model. You can download the file, the Visum version file from the internet. So yes, of course, you need to invest, I think, a little bit, maybe to have a little bit more detail in your city. But in general speaking, it is directly usable. If you don't have the model directly by the ministry or something, I said we have this model to go approach, so the data availability is much more better, and and it's much easier to build up the data. So the most critical cost perspective is building up those models, and afterwards using it, and then as I said, in the case of Baden-Württemberg, we have the cool situation that normally our software is needed, that you can play around with it. This is helpful, to be honest. But in the end, I don't know how long it took, to be honest, to build up the Baden-Württemberg model. But I would say at least, I don't know, half a year or something. So it is quite and then you need, it's not the whole thing just building it up, but of course you have to have a lot of discussions also with the ministry in that case and so on. So this was the huge effort, but then using it, relatively cheap.
Okay, thank you. Lucas, just to give a sense.
So I think this is where we differ a bit, right? So we put a lot of emphasis on the automation, which really reduces the cost. I think we're bringing in two paradigm changes, which is we're not here to just build the model and then wait for it to kind of be outdated after 4 years, but really having this process of automatically updating it and making sure that it keeps living, right? And so keep being a twin after all, and not remains a twin 2 years ago. I think that's one of the changes that we're trying to push forward. And the second one is really we're pushing very much on the usability, which means that a larger crowd can use it essentially. And I think really also distributing it to as many people as possible, which again then makes the investment less expensive compared to the number of users that can use it. That were my 2 points.
Maybe just to add one thing, and or to answer on one of the things you mentioned, Lucas, is especially for the case of Baden-Württemberg. I know that you build a model and then you're using for the next 5 years. No, they want to really have a cycle where where in a permanent way also renew and also update the model. So I know I get
Cool.
this point, but this
Very good.
is in this case not the case anymore.
And my intention was not to pitch one against the other. It was simply just to give a sense of scale to municipalities out there who might be thinking, okay, well, let's take a look at this, and just to give a rough sense of what that could mean. Thanks. And the second one, just as a send off, because both of you have mentioned, the use of artificial intelligence. But I would say, like in general in society, you would see artificial intelligence as this kind of almost like a digital twin in a way. It's like a kind of a companion. It can, give you lots of insights. It can, be very interactive. And so I'm just wondering, you've highlighted the fact that artificial intelligence, as I understood it, could be embedded into the digital twin as an analytical tool that can give you extra insights that can improve the tool overall. But don't you see that potentially in the end, a bit like simulation, digital twins, ultimately everything will just become kind of artificial intelligence, and artificial intelligence will kind of replace digital twins? Anyway, I'd love to have a final reflection from you on that. The difference between simulation, digital twins, and artificial intelligence. No, but a reflection on the future of how you see that. Lucas, please.
It's always tough to go first, otherwise I could have just said I agree with Ralph. But no, I actually think here, so for the time being, I think simulation have one big advantage, right? Which is kind of this traceability aspect, which is in the eyes of many of our clients super important, that it's not just a black box where you understand actually what is the main driver. If I change this parameter, this is going to happen. And I think that's one of the key assets of a simulation. Now, I am not saying, and I think there's quite some research going on, at least from the university context that I sometimes have, that we're trying to replicate the behavior of a simulation, which essentially is the behavior of traffic or mobility, right? With a machine learning kind of approach, right? That has an advantage, which means that you train much on such a simulator and then are able to run it very quickly, right? So you do not have to wait for hours and hours until you get a response from a, let's say, slow mechanistic simulator. So I would say there's potentially a trend, not now, not tomorrow, but later, that this could happen. And I think that would be actually very interesting to follow up.
Okay, thanks, Lucas. Ralph, your thoughts?
Have you ever asked ChatGPT, you want to go for a car wash, should you go by foot or should you take the car? You know that answer.
Love
So
it.
it says, oh, it's just 100 meters. You can go by foot. And until it's in that way that also I think you still need to use it in a clever way, in your own way. If it's, I hope, to be honest, I hope that it will never be that AI fully overtakes or that takes the whole future of modeling and simulation, because you still need, I think, a sense of responsibility, and also of, I would say, to have the knowledge and everything to, yes, use AI in the correct and the proper way, but you still need to have your own brain to implement the whole thing. So in short, shit in, shit out. So I would not now trust an AI to fully take over. I would just say one additional thing where AI could also extremely help is, as I said, mobility is a kind of a complex situation, and also I would say with PTV Visum we have quite an enhanced software but AI could help us in dealing with this kind of complexity within the software. So just, hey, I want to have a certain within our software, I want to have a certain solution applied. Then I ask AI, how can I do that? And then it helps you to get a result. I think if you think about that way, you can also improve the usability of such software in a very good way. Also think about of this kind of application.
Wonderful. Thank you so much, Ralph and Lucas. You've been extremely diligent in answering so many questions. There were many questions and comments coming at us from the chat. I tried to take a maximum number up, and I think you answered many of them. So really, thank you so much for your time, all the preparation you put in as well to give us a sense of the use cases. And I think you both end up first in that bicycle race. You know, equal first on the podium. Thank you so much, Ralph and Lucas.
Thanks a lot, Lucas. Thanks a lot,
Thank
Joe.
you. Thank you.
So that was episode 33 of the Mobility Talks. Do you think that digital twins can be a useful tool to improve urban mobility? I think we've seen some very practical case studies on the microscopic level, on the macroscopic level, where we can really see how digital twins can support decision making when it comes to strategic transport planning. But then we also saw a tool that was very much looking at real-time scenarios and how you can be extremely responsive and looking at different scenarios real time. So there are multiple ways in which digital twins can be used for urban mobility. We looked at also some of the challenges in building the setup, which can be pooling a lot of data together across regions, but then also looking at very, very specific neighborhoods or very specific areas in a city. Everything is possible. Obviously, the recording will be available, so you'll be able to reflect back on these presentations. The presentations will also be made available on the EIT Urban Mobility website, and we hope this was insightful. I tried to keep up with all the comments and questions coming at me. There were many, so thank you so much for your activity and for engaging with the conversation and with our two speakers today. And I will wish you then a good rest of the day, wherever you might be in the world, and hope to see you at our next Mobility Talks. Take care. Bye-bye.